Hi everybody, Denny here from ColdQuanta with 3 minutes of quantum computing. I'm always on the lookout for fun problems to map to quantum computers. Last year I noticed a puzzle in my newspaper called 2 Not Touch. This is what it looks like. I reached out to the author of these puzzles, Jim Bumgardner, and he gave me permission to talk about them in today's video. Check out his website for lots more puzzles. Jim calls these puzzles StarBattle, and so I'm going to follow his lead. Here are the rules for solving a StarBattle puzzle. The grid is divided into regions. It's your job to put one star in each region, subject to a simple constraint. Stars cannot be neighbors. That means 2 stars cannot be next to each other side by side, up and down, or diagonally. Additionally, each region has to have 1 star. So here's an example of an 8x8 puzzle, and here is its solution. You can see that each region has exactly 1 star and that none of the stars are neighbors. StarBattle puzzles can be bigger than 8x8. Here's a 10x10 puzzle. There is one modification to the rules for bigger puzzles. With the 10x10 puzzle, the number of stars in each region is not 1, but 2. Jim also creates 12x12 puzzles. For those, there must be 3 stars in each region. Now our task is to convert this puzzle statement into a QUBO. What's a QUBO? Quick answer. It's an intermediate problem representation that allows you to get stuff onto a quantum computer. But since we're going to actually build a QUBO for StarBattle, we need a slightly longer answer. A QUBO is just a function of some variables. Each variable has a 0, 1 value, so we can call them binary variables. And the form of a QUBO is really simple. We can have linear terms. These involve a single variable multiplied by a weight, and we can have quadratic terms. These are the product of 2 different variables multiplied by a strength. I'm a big believer in having a constant term in a QUBO too. You'll see why later on. So now you know what a QUBO is. Since a QUBO is just a function, if you know what the values of its variables are, then you can evaluate it. So what do I mean by saying that we want to convert StarBattle into a QUBO? I mean 3 things. First, our QUBO's variables will correspond to the cells in the puzzle. So if we have an 8x8 StarBattle puzzle with 64 cells, our QUBO is a function of 64 variables. You can imagine each variable living in a cell in the 8x8 grid. If you put a star in the cell, the variable is 1. If there is no star in the cell, the variable is 0. The second point is that for a configuration of stars in the grid, we can evaluate our QUBO to get a number. Here's a small example with a 3x3 grid and 9 variables. The third point is that when we convert our StarBattle puzzle to a QUBO, we want that QUBO to have one very important property. When the stars solve the puzzle, the corresponding QUBO value is minimized. Because I allow a constant term in a QUBO, I can require that the QUBO has its minimum at 0. When the stars do not solve the puzzle, the QUBO value must be positive. If we can do this, solving the StarBattle puzzle becomes equivalent to finding the minima of a QUBO. A quick comment. Although a QUBO is a simple thing, building one to capture a problem like this may not be easy. And it may not feel like you are making forward progress because you are converting one problem into another problem. But with practice, you'll see that there are many techniques for building QUBOs. And once you have a QUBO, you are well on your way to being able to run your problem on a quantum computer. Next week, I'll construct the QUBO for StarBattle and we'll start running it on real quantum computers. That's it for today. Thanks for watching. Bye everybody.